Welcome everyone to part 4 of the sci-fi first-person shooter tutorial series. In this video, we're going to finish customizing our projectile by allowing it to apply damage to our characters, having it spawn a decal when it hits surfaces, and adding that sound attenuation that I mentioned in the previous video. Let's not waste any time and we'll jump right into it. First, we need to open our master projectile blueprint, and we can double click on that to do so. And I wasn't really a big fan of our blaster bolt speed in the previous video. It seemed to be firing a little slow, and gravity affected it a lot more than what I imagine it would. So let's change these aspects of our projectile by going to the projectile movement component in the components tab, and we can alter them directly here in the details panel. That's actually one of the main benefits of using this type of movement component. The initial speed variable is a little bit low. In fact, let's go ahead and change that to a value of 4,500. This is the initial speed that the projectile fires when it's spawned. For our max speed, this is the maximum speed that our projectile will ever go. And I actually don't want to have a maxed value for this, and we can change it to 0 in order to not have a cap on our max speed. As you can see, if you hover over it, it'll give you the details, and it says that 0 means no limit on the speed. That's in case we shoot downward and maybe the projectile picks up some speed. We don't really want to have any cap on how fast it goes. And lastly, I'd like to lower the projectile gravity scale so that our blaster bolt will almost hover more like a traditional sci-fi projectile. And I think setting this to something like 0.4 will give us an accurate representation of those sci-fi projectiles. With this scale, the projectile will eventually drop down over extremely long distances. Underneath, we have the projectile bounce tab, which determines whether or not our projectile will bounce. Surprisingly, I'm going to leave this setting here, projectile bounce, set to true. We're going to script that projectile to destroy itself whenever it hits anything, but maybe later, when we expand on its scripting, we might want to allow our projectile to be reflected off of armor or something. So this setting should definitely be set to true, otherwise the projectile will just stop its movement completely whenever it hits anything. And that's all we really need to do for our projectile movement component. If you test it out, you can see that when we fire, our projectile isn't going directly where our crosshairs are on our heads-up display. A quick fix is to slightly alter the location of the crosshairs on our heads-up display to match where we're currently firing. This was an issue on our showcase video, and it definitely bugs me whenever I watch that, so let's go ahead and fix it now. We can navigate to our widgets folder and open up our first-person heads-up display. Once again, we have some VR code set up in the event graph that we can delete right away by left-clicking, selecting all of it, deleting, and then we can just plug the execute back into the execute for our draw texture. Compile and save. And really, all we need to do is alter the offset that's already set up for our size Y here. You can see this offset is set up, and we'll create an offset for our size X. The value I ended up using for size Y was 30. Let's actually delete this comment here. And we can copy and paste this node to reuse it for the size X. We can plug this in here and plug this into that connection. And the value that I used for size X ended up being -4. Of course, you can also play with these numbers if you'd like to see if you can get it a little more accurate than what I'm doing. Also, we can scroll over to our tint color and change the tint of our crosshairs here if we'd like. Unfortunately, if we expand this, we can see our texture for our first-person crosshair is red. So your tint may come out strange if you change these values to something like a pure green. That's why I generally recommend using white for your textures, so that if you change the tint in Editor, the tint will accurately reflect the on-screen color for the texture. For demonstration purposes, I'm going to compile and save, and although this is showing 100% green, when we play in Editor, we'll see that it's actually showing a black, which is not what we were going for when we changed the tint color. I'll change this back to a pure white, compile and save, and when you change the tint to pure white, it basically displays the normal texture colors. Alright, so now we have our weapon firing pretty accurately, but our projectile just kind of bounces all over the place. And if we hit another character, it won't do any damage, it just bounces off. We'll want our projectile to do two different things. One if it hits a character, and another if it hits anything else. So let's navigate to our BP Master Projectile, and we can move all of this scripting just further to the right since we're not going to be needing it right now. One of the best ways to check to see if our projectile hit one of our character blueprints is to use a cast node. And before we fire the rest of this script here, we can cast to our other actors. So first let's cast to our Master FPS character blueprint, which will effectively tell us whether or not the hit actor is that type of blueprint. Off of event hit, we can drag off of the other actor object reference and cast to our BP Master FPS character. Go ahead and plug in the execution pin, and now we have two execute paths. The top execute path will only fire if the hit actor is a Master FPS character or a child of Master FPS character. And the cast failed path will fire if the hit actor isn't either of those. Let's complete the top path first. If we do hit a character, we need to apply damage to that character. Luckily, the engine has a built-in damage event that we can call for our character, and we'll set up what that damage event does back in the Master FPS blueprint later. So let's drag off of the object reference, type in apply damage, and put that in place. We'll get a few defaults for the apply damage node, but the only ones we care about are the base damage and the damage causer. For damage causer, we can actually just type in ourself since it will be the master projectile that does the damage. And for base damage, in the showcase, I simply set the amount to be 0.34 so that everyone would die in 3 hits. But we can use what we learned in the last video and set this to a variable and make that variable instance editable and expose on spawn. That way we can set the damage that each projectile does based on its firing mode in the next video. This gives us more freedom and easier customization. With that done, we can now connect the execute to the branch node. With that set up, we'll apply impulse if our character is ragdolling, since it will be simulating physics. But off of the false path, we'll just want to destroy our projectile, so we'll type in destroy actor. Alright, so we have everything set up for if the projectile hits our player or a child of our Master FPS character. It applies damage, then checks to see if that character is simulating physics. If it isn't, it'll just destroy itself. If it is simulating physics, it'll apply an impulse at location and then destroy itself. Let's delete this comment right here. We won't be needing that. But what if we go back and check to see if we don't hit a character? So we're going to have a cast failed path here as well. And the first thing we'll want to do if we don't hit a character is spawn a decal. A decal is a special type of material that can add detail on top of another existing material or mesh. In order to create the decal that we're going to use, you'll need a small asset pack that I put together, and it'll include all of the textures and audio that we'll be using for the rest of the tutorial series. I'll include a link in the description. You'll want to download it from my Google Drive, then unzip the contents, open up the folder, and we'll want to add these two folders to our project. I named the folders and files with the same naming convention that we've been using, so it should be pretty easy. We'll just select AU download, AU for audio, and drop it into our audio folder, and then T for textures download, and we'll drop that right into our textures folder. Just so that we stay organized, I'm going to click on both of these and set their color to that red, and then audio, I'll set that color to the purple, and save all. Now we'll need to create a decal material from one of the textures that we just imported. So let's go back to our texture download folder, and that material will be made from the T decal blast mark. We can right click on it and select create material. We'll call it something like M underscore decal underscore master, in case we'd like to make any other decals in the future. And we should drag this into our materials folder and open that up. Let's open up that material and get to work. Like I said in the last video, materials can really be their own series of videos. We're only going to plug in one texture and change a few properties in the details panel. Since we've created this material from a texture, we can already see that texture here in the graph, but let's right click on it and convert it into a parameter. Converting it into a parameter, once again, allows us to easily change it whenever we make material instances, because we can override the parameters. We'll call this parameter base texture. Now deselect the parameter, and in our details panel, we'll want to change the material domain for our material. We'll change it to deferred decal, which it needs to be in order to function as a decal. Immediately we'll get a notification that we should change the blend mode to translucent to save performance. So let's go ahead and do that by selecting opaque and changing it to translucent. And lastly, we'll need to change the decal blend mode to debuffer translucent color. And then finally we'll plug in the alpha into the opacity to mask out the blank areas of the decal. Now we're done creating our decal material. Let's close the material, minimize our open blueprints, right click on the master decal, and create a material instance, which we can call mi decal underscore blast mark. And we actually don't need to edit this at all. We can go directly back to our projectile blueprint, our master projectile. From the cast failed execute, we can drag out, and like with most things, there are multiple ways to spawn a convincing decal. The first way is called spawn decal at location. As the name suggests, this will spawn a decal at a specified location. We can specify its size, location, rotation, and lifespan. The lifespan being the time before it destroys itself. The second method to spawn a decal is called spawn decal attached. Spawn decal attached is generally the preferred choice in many instances because it can be attached to a component and move with that component should any impulse or movement be applied to it. But to make things easier on ourselves, let's choose spawn decal at location. We can specify to use our decal mi blast mark. I ended up using a decal size of 30, 30, and 30, but we'll change that in just a moment. The location that we spawned the decal will be the hit location from our event hit. So wherever it hits, that's where the decal will be spawned. And the rotation will be important to specify since we'll be hitting surfaces with different rotations. For this, we'll need to make a rotator from the normal of the surface that we hit. So we'll drag off of the hit normal, type in make rotator from X, and plug that directly into the rotation for our spawn decal. Basically, this will take the direction of the hit normal and rotate our decal to match. And lastly, we'll want our decal to destroy itself after a relatively short amount of time. In my case, I'm going to choose 5 seconds. And with this node being completed, the last thing we'll have to do is destroy our actor so we can plug that directly into destroy actor. And clean this up a little bit by dragging these back. I'm going to expand this comment box just so that it envelops our entire event hit. And now our projectile is working as intended. I think we'll end the video just with one small cleanup step from the last video. I promised that we'd make an attenuation setting in the last video, and we never did that, so let's do that now. An attenuation setting is what tells the engine how the volume should change based on a sound's distance from the listener. To make one, we can navigate to our audio folder, right-click in the content browser, go down to Sounds, and click on Sound Attenuation. We can give it a simple name like Sound Attenuation _ Natural Falloff. If we open up the Sound Attenuation, we'll be able to see all of the values and properties that we can change. We'll keep it simple though with a linear attenuation function, which means that it will evenly drop the volume as you get further and further away until you're out of range. But I think I'll change the fall off distance to something just a little bit shorter, that way I don't hear everything from super far away. Later when we have enemies firing projectiles, you'll be able to play with this value just to find something that you like and something that works for you. Let's save this and go back to our master projectile, and with that sound attenuation created, we can select the drop down under our attenuation settings, and we see our newly created sound attenuation all alone. With that done, our projectile is nearly complete. There's one last thing we need to do. When we spawn a decal, we have the decal set to a specific size, and that size never changes regardless of what firing mode we're in. So what we'll need to do is set the size to a variable. And an easy way to do that is to drag off of the decal size and make a vector. From that vector, we'll promote one of the float values to a variable, and we can call it size. Plug the size into the x, the y, and the z so all of them will be the same value as the size float. And we can make the size instance editable and expose on spawn so that we can change it based on the firing mode in the next video. And with all of that done, our projectile is finally fully completed. That leaves us in an excellent place to end the video. We have once again covered a ton of stuff. Everything from customizing our projectile movement to updating our heads-up display to match our trajectory of our projectiles, scripting what our projectiles do based on what it hits, spawning a decal, and creating a sound attenuation. In the next video, we'll create 3 different firing modes for our master first-person shooter character, and we'll be able to toggle those firing modes with the touch of a button. Thank you so much for watching. I really hope you learned something. I'm Jovan D, here to help you think like a game developer. Stay tuned for the next video in the tutorial series.